Caption. An enormous mosaic of Stephan's Quintet is the largest image to date from NASA's James Webb Space Telescope, covering about 1/5 of the Moon's diameter. It contains over 150 million pixels and is constructed from almost 1,000 separate image files. The visual grouping of 5 galaxies was captured by Webb's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI. With its powerful infrared vision and extremely high spatial resolution, Webb shows details never before seen in this galaxy group. Sparkling clusters of millions of young stars and starburst regions of fresh starbirth grace the image. Sweeping tails of gas, dust, and stars are being pulled from several of the galaxies due to gravitational interactions. Most dramatically, Webb's MIRI instrument captures huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. These regions surrounding the central pair of galaxies are shown in the colors red and gold. This composite NIRCam MIRI image uses 2 of the 3 MIRI filters to best show and differentiate the hot dust and structure within the galaxy. MIRI sees a distinct difference in color between the dust and the galaxies versus the shock waves between the interacting galaxies. The image processing specialists at the Space Telescope Science Institute in Baltimore opted to highlight that difference by giving MIRI data the distinct yellow and orange colors, in contrast to the blue and white colors assigned to stars at NIRCam's wavelengths. Together, the 5 galaxies of Stephan's Quintet are also known as the Hickson Compact Group 92, HCG 92. Although called a quintet, only 4 of the galaxies are truly close together and caught up in a cosmic dance. The 5th and leftmost galaxy, called NGC 7320, is well in the foreground compared with the other 4. NGC 7320 resides 40 million light-years from Earth, while the other 4 galaxies, NGC 7317, NGC 7318A, NGC 7318b, and NGC 7319 are about 290 million light-years away. This is still fairly close in cosmic terms compared with more distant galaxies billions of light-years away. Studying these relatively nearby galaxies helps scientists better understand structures seen in a much more distant universe. This proximity provides astronomers a ringside seat for witnessing the merging of and interactions between galaxies that are so crucial to all of galaxy evolution. Rarely do scientists see in so much exquisite detail how interacting galaxies trigger star formation in each other and how the gas in these galaxies is being disturbed. Stephan's Quintet is a fantastic laboratory for studying these processes fundamental to all galaxies. Tight groups like this may have been more common in the early universe, when their superheated infalling material may have fueled very energetic black holes called quasars. Even today, the topmost galaxy in the group, NGC 7319, harbors an active galactic nucleus, a supermassive black hole that is actively accreting material. In NGC 7320, the leftmost and closest galaxy in the visual grouping, NIRCam was remarkably able to resolve individual stars and even the galaxy's bright core. Old, dying stars that are producing dust clearly stand out as red points with NIRCam. The new information from Webb provides valuable insights into how galactic interactions may have driven galaxy evolution in the early universe. As a bonus, NIRCam and MIRI revealed a vast sea of many thousands of distant background galaxies reminiscent of Hubble's deep fields. NIRCam was built by a team at the University of Arizona and Lockheed Martin's Advanced Technology Center. MIRI was contributed by ESA and NASA, with the instrument designed and built by a consortium of nationally funded European institutes, the MIRI European Consortium, in partnership with JPL and the University of Arizona. For a full array of Webb's first images and spectra, please visit https://webbtelescope.org/news/first-images. Image credits: NASA, ESA, CSA, STSCI. Audio description produced by the Blind Muse Foundation, narrated by Tristan Snyder.